Now let us move on to the next question. Here the function is defined in z to z and f of x equal to x cube. So domain, codomain, and this is in z, that is integers, and this also in z, which is integers. This is x and this is f of x equal to x cube. Now we will go for one-to-one check. So we are assuming again x1 and x2, they are mapped to f of x1, which is equal to f of x2, that is, it is a many-to-one function. We get x1 cube equal to x2 cube, and as we solved in the previous question, we will take x1 cube minus x2 cube equal to 0, and we will expand this, and then we get x1 equal to x2. Hence, f is injective. Whether it is onto? No, it is not onto. Because for the same reason, y power 1 by 3, which is or which can be a fraction, will not exist in z. So we will move on to next question. We need to prove that the greatest integer function, which is defined in R to R, given by f of x equal to greatest integer function of x, is neither one-to-one nor onto, where gi of x, greatest integer function x, denotes greatest integer less than or equal to x. So first we will understand what is a GIF or greatest integer function. Let's say I have number 0 and I have number 1, and I am considering the number 0.2. Now the greatest integer function 0.2, it is equal to 0. In the sense, in the given number, what is the integer available we need to take. So we should ignore the decimal part. So 0.2, here still the greatest integer is between 1.1, GIF of 1.1 will be equal to 1. At the same time 0.9, since it is closer to 1, you cannot take 1. So this is a simple illustration of GIF. Now let us try to prove that it is not one-to-one nor onto. So first let us take two elements in the domain. Let's call that as x1 and x2. So this is domain and this is codomain. This is defined in R, this is also defined in R, and this is mod x. Sorry, this is greatest integer function x. So I take two numbers x1 and x2. Between two consecutive integers a and b. So let's say a is here and b is here. So between a and b, I am assuming two numbers x1 and x2. A is lesser than b. That's what is our assumption, and x2 is greater than x1. Now f of x1 equal to f of x2, because that is how we proceed in one-to-one check, assuming that it is a many-to-one function. Now GIF of x1 or GIF of x2 equal to a, because x1, this is the greatest integer function, greatest integer available, and x2, still this is the greatest integer, and hence it will be equal to a, where a is the integer that is lesser than both x1 and x2. But x1 is not equal to x2. So after this operation we didn't get x1 equal to x2. What we got is both these numbers, it point to a. So to make things clear, let's say in domain we have number 0, 0.1, 0.5, 0.8 and 1. In codomain We have numbers 0, 0.1, 0.5, 0.8 and 1. 0 is mapped to 0, 0.1 is mapped to 0 because this is GIF. 0.5 is also mapped to 0, 0.8 is mapped to 0. Now we will go for onto check. Again we take domain, codomain and greatest integer function x here. So this is defined in R, this is also defined in R. So let's say I take numbers 0.1, 1, 1.8 randomly, and I take here 0, 0.1, 1 and 1.8. Now 0 is mapped to 0, 0.1 is also mapped to 0, 1 is mapped to 1 and 1.8 is mapped to 1. Notice 0.1 or 1.8 doesn't have any pre-image here. Thus, these fractions will be left out without any pre-image and hence it cannot be onto.